Hey, before we dive into the Algebra 2 content, we of course need to review some Algebra 1 skills. So today we're going to look at exponents, simplifying exponents, and then the next thing that I have here on our notes is simplifying radicals. Guys, these are going to come back up over and over and over. These are very essential skills for us as we move forward. So if you're rusty or you need a refresher, now is the time to soak this up. So we're going to look at your exponent rules here at the top. The first one we're going to talk about is your product rule. So if I have x to the a times x to the b. So if I have two powers, same base, notice the x's, the bases have to be the same. But if your exponents are different, you can combine them by adding your exponents. So I'm going to do x and show it as a plus b here on my notes. I'll give you an example. If I have x squared times x cubed, bases are the same. You can add those and have x to the fifth. Your power rule, so if you have a power raised to an exponent, a power to a power, the way I remember that is it's super powerful. So your rule is you can multiply those two exponents together. So an example, x squared to the third power, multiply those together and get x to the sixth. Your quotient rule, if you're dividing two powers, you are going to subtract, and it is top minus bottom. So let's say we have x to the seventh over x squared. When I subtract that, 7 minus 2, I have x to the fifth as your example. Your negative exponent rule, if you have a negative power, it is equivalent to 1 over x to the positive exponent. So it moves down into the denominator. So an example, let's have x to the negative 2 is equal to 1 over x squared. Now we're not allowed to have negative exponents when we're done. So we are going to use this rule a lot. Likewise, let me give you a different color. If you had 1 over, and your negative was in the denominator, x to the negative 2, that would be equal to x squared. So if it's a negative in the denominator, it moves up to the numerator and becomes positive. So wherever your negative exponent is, numerator, it moves down to the denominator. Denominator moves up to the numerator. And again, we have to get rid of those negative exponents, so we're going to use that rule a lot. Zero exponent, this one's my favorite, super easy. Anything to the zero power is 1. So I hope you remember this one. So if I have even something crazy, let's say A, B, quantity, all raised to the zero power, all of that is equal to 1. So that's a helpful one. We love that one. If you have questions about the negative exponent or the zero exponent as to why, ask me. I can show you why those rules are. So let's move on down and put these into action. So express the following in simplest form using only positive exponents, so no negatives here. Let's start with this piece. So we've got 2 times p squared raised to the fifth over 10 p to the sixth. I'm going to use that power to power rule and simplify this as 2 times p to the 10th, leaving everything else, 10p to the sixth in the denominator. From there, a couple things. Your numbers are still numbers. So the 2 and the 10, those are still coefficient numbers. They don't have special rules. So I'm just going to think of them as a fraction and simplify that to 1/5. And then let's look at the p's. So I have p to the 10th over p to the 6th. That's that quotient rule. I'm going to subtract 10 minus 6. I'm going to show that step here, 10 minus 6, and I'll have, you can write 1, you don't need to write 1. 10 minus 6 is 4, p to the 4th over 5, and you can just write that. Final answer. Okay, so we use the power rule, we simplified the fraction piece, and we use the quotient rule there. Number 2, 3a squared over 3 times a squared raised to the 4th. You got a similar thing going on down here. Let's use power rule, leaving everything in the top the same. Power to power, multiply. 2 times 4 makes 8. I'm going to look at my numbers here. 3 over 3 is 1, or it cancels out. And then I'm going to do a squared divided by a to the 8th is my quotient rule. I'm going to subtract. So I'm going to use that quotient rule. We're going to have a to the 2 minus 8. That's going to give me a to the what? Negative 6. Wait. You can't have negative exponents, right? So if you have a negative, you've got to move it down into the denominator, use a 1 as a placeholder for your numerator. And there we have it, 1 over a to the 6th. Number 3. Now look at this one. We've got parentheses with 2 things inside. You've got a 5 and you got an m squared. Those are 2 things. And each of them is being raised to the 3rd power. So careful here. Make sure you do 5 to the 3rd. And we also have m squared is being raised to the 3rd. So this looks similar to some of the other problems that we've done now. Power to power multiply. Now let's see here. In the denominator, we had 5 or 5 to the 1st. So you can do it a couple different ways. You can think about using exponent rules. And since they are same bases, you could do 5 to the 3rd, like 3 minus 1, which is 5 squared. Or you could solve this out, simplify it. 5 to the 3rd is 125 over 5, and then divide, whichever way you want to do that. So 125 divided by 5 is going to give us 25. I've got m to the 6th divided by m to the 9th. Subtract those. I'm going to show that 6 minus 9. 6 minus 9 is going to give me negative 3. But you're not allowed to have negative exponents. Move it down into the denominator. So 25 is going to stay in the numerator. M to the 3rd goes in the denominator. Number 4. Now, the first thing that draws my eye is that negative exponent, w to the negative 6. I can't have a negative exponent, so we'll take care of that. But first, let's look at the 12 and the 4. Those are still numbers. I can still simplify as a fraction, or I can divide them. 12 divided by 4 is 3. Let me just show our steps here. So if I was using the quotient rule, if you want to use quotient rule for those w's, you would have w to the negative 6 minus 2. There's a couple different ways you can attack this. And so your mind might go a different pathway than mine, but we should all end up at the same place. So if I use quotient rule and I subtract, I get w to the negative 8. And still you can't have those negatives in negative exponents, so move it down into the denominator. The other thing you could have done is way up at the very beginning, moved the w to the 6 down because it was negative and kept it with the w squared in the denominator, and then used your product rule to add those two together to give you the 8 for the exponent. Either way, that's what I meant. There's different pathways, different strategies we might take, but we should all end up with the same final answer. Number 5, 10n over 2 times n to the negative 3 raised to the negative 4. So this piece is your power to power. So I have 10n over 2. The n to the negative 3 is the only one that has that exponent. Multiply your power to power. So you have n to the positive 12. Let's simplify the numbers. We got 10 over 2. I can divide that and get 5. You have n to the first. You can use quotient rule. I can show that here, that I would subtract those and get negative 11. I can't have a negative exponent, so bring it down into the denominator. Final answer, 5 over n to the 11th. Number 6. Again, you've got 2 things inside these parentheses. I'm using a purple marker. It's hard to see, but each of those things in the parentheses is getting that cube. So I have negative 5 cubed. Notice how I use parentheses. This is such a good question. I'm so glad I put it on our notes because we are going to cube a negative. If you are using negative numbers and you are squaring them or cubing them, it is very important that you put it in your calculator correctly so your calculator knows what you want. Notice I drew parentheses around my negative 5 for a reason. So then I'm also going to have p to the negative 2 cubed, kind of just rewriting my problem here. And let's clean it up. So slide our paper over just a bit. Negative 5 cubed, that's negative 5 times negative 5 times negative 5. So that's going to actually give you negative 125. If you type it in your calculator, I guess this one wouldn't mess up. But sometimes if you don't put parentheses around your negative, um, especially if you did negative 5 to the fourth, negative 5 to the 4 should end up as a positive number. But if you didn't put parentheses around your negative, your calculator will tell you it's a negative. So watch out for that. Power to power on the p here, negative 2 times 3 is negative 6. You have negative 4, p to the negative 1. All right, from here, 125 and 4 are not going to divide evenly, but what I can do is get rid of those two negatives there and just have positive 125 over 4. That's the best I'm going to be able to do as far as simplifying. And then you can work at this two different ways. I really don't like negatives, so I might flip these to their proper place and then work from there. Or I'll just show, we'll do negative 6 minus, a negative 1. So whichever strategy you might like. This is going to give me p to the negative 5th over 4. Can't have that negative 5 on that p, so 125 over 4 p to the 5th is going to be our final answer. Now, like I said, I kind of like to move my negatives before I get to working. So if I had the 125 over 4, moved p to the 6th down and p to the 1st up, that just makes my brain happy. And then you could do like p1 minus 6, and that gives you the negative 5. So you kind of get to the same place, whichever one you prefer. Okay. Oh, I didn't change my negative here. P to the 5th. So that's our final answer there.